Let's move on to part 4 of ESE previous year's questions. In part 3, we have discussed all the questions from the year 2017 except for one. This is your question from the year 2017. VI characteristics are given to you and they are asking what is this element and what is the value of this element. Okay. After completing the sheet regarding RC and RL circuit, you will be easily identifying what are these elements. Okay. But for the time being, what we are doing is we are finding out the slope, that is di by dt, and then you put it in the formula of voltage across an inductor. Okay, so you put it in this formula and you get the answer. Now let's move on to the year 2016. We are having so many theory questions from this particular section over here. What we are doing is, the first question we are having is, a short in any type of circuit, whether it is series, parallel or combination, causes the total circuit resistance to drop, power to drop, current to increase or voltage to increase. Which of the following are correct? Okay, so the answer is 1 and 3. Okay, your resistance, total resistance drops and total current increases. The second question we are having is, the mesh current method, first statement we are having is, works with both planar and non-planar circuit. Second, it uses KVL. Which of the following are correct? Okay, so the answer is 2. Okay, only this is correct. It uses KVL. This statement over here is wrong because it is not applicable for non-planar circuit. Okay, to be kept in mind. Let's move on to the next question. In nodal analysis, the preference of reference node is a node that is connected to ground, many parts of the network, the highest voltage source. Which of the following are correct? Okay, as I've mentioned so many times in my previous videos, that the reference node in nodal analysis is the one which is connected to many parts of the network. Okay, hence the statement number 2 is correct, which makes the option B as the most appropriate one. Now let's talk about the next question. In a parallel resistance circuit, opening a branch results in total resistance increment, total power loss, no change in total branch voltage. Which of the following are correct? Okay, 1, 2 or 3. This is your answer. Okay, all these three things happen when you open a branch in a parallel resistance circuit. Okay, your total resistance increases, total power decreases, and no change in total branch voltage happens. Now let's move on to the next question. We're having three 30 ohm resistances in parallel across ideal voltage of 40 volt. What would be the equivalent resistance seen by the load connected across this circuit? So the answer is 0 ohm. Okay, there was one statement in my video regarding source transformation, that was with regards to internal resistance of ideal voltage and current source. Okay, from that particular statement, okay, that was 1 or 2 line statement, from that this question has been arised. Okay, so make sure you study each and every statement of my notes. Now we are having the next question as, two bulbs 100 watt 250 volts and 150 watt 250 volts are in series across the supply of 250 volts. What is the power consumed by the circuit? Okay, this is your supply 250 volt, this is your 100 watt 250 volt and 150 watt 250 volt bulbs in series. So the total power consumed would be, how to add power in series? Okay, this is a concept you have to keep in mind, that when power is in series, you add them in such a way that is used when two resistances are in parallel. Okay, this is a way that we use when two resistances are in parallel. So when power is in series, two elements are in series and you have to calculate the total power, you add them in such a way that is similar to when two resistances are in parallel. Now we are having this next question over here. This is an important question. Okay, they are asking the voltage VAB, okay, voltage across these two terminals. Okay, this is a very different question and I will be explaining it in detail in a separate video, only this particular question over here. Why? Because this type has been asked in UPSC IAS. Okay, for those students who are taking electrical engineering as their optional subject, okay, this question has been asked in previous years. Also, this type of question has been asked in ESE mains. Okay, so make sure you focus a lot on this question and I will be making a separate video on regarding this particular question only. Okay, so for the time being, what we are doing here is, first of all, this is your reference node and this is having voltage of 5 volt. Okay, this is your positive 5 volt terminal. So here your VC will be 5 volts. Now what we are doing is we are taking we are performing nodal analysis at this particular node. Okay, then this would be this way, and this way. So three elements would be there, 1, 2 and 3. Similarly we will be applying nodal analysis this and this way. Okay, so at node A it is your plus A plus 1. Okay, why? Because current is available. Okay, then we are doing voltage minus voltage upon resistance. Okay, voltage minus voltage upon resistance, and then we are doing voltage minus ground upon resistance. Okay, we will be putting ground on this particular terminal over here. So it will be VA minus 0 upon 4, VA minus 5, because this positive terminal is here, so this VC will be 5. So VA minus 5 upon 1 ohm. So we will be writing equations, and similarly we will be writing equations for VB as well. Okay, so this will be your equation, and on solving you get the value of VAB as minus 0.8 volts. Now the last question from the year 2016 is what we are having. The question is, n number of resistances of same value are connected in series, then the equivalent resistance is 50 ohms, and when connected in parallel the equivalent resistance is 2 ohm. Then what is the value of that resistance? Okay, suppose there are n number of resistances. When connected in series the equivalent is 50 ohm, and when connected in parallel the equivalent is 2 ohm. So what is the value of R over here? So we know that when you add in series it would be nR equals to 50, and in parallel it would be R upon N equals to this. So on using these two equations you will easily calculate the value of R as 10 ohm. Then in 2015 no questions have been asked, and the questions that have been asked in 2014 would be discussed in part 5. That's all for today.